Hello and welcome to the Knowledge Catalog. Welcome back to the Knowledge Catalog for those who have been here. You may have noticed that I've been out for a while. I mean, in a while, kasi I didn't really need to upload new content because we had some sort of a break in school. So we had like a couple of weeks na wala kami talagang mga new discussions na kailangang i-open. So, ayun, I also had a break and I took that as an opportunity to focus on something else, which is writing my module for my thesis. So, ayun, for those of you who are looking for me, I'm still here. I'm still here. In this version, in this season, I know, in this edition of the Knowledge Catalogs Earth and Space Science, we are going to continue our discussions with learning competencies number 3 and 4. So for learning competency number 3, we have explaining what happens when volcanoes erupt. And then we are all going to continue that with the discussions for illustrate how energy from volcanoes may be tapped for human use. And so if you want to have a copy of this presentation, you may contact me through my Facebook account, which is yung link nasa may description. And then if you want to follow through with some sort of a with some sort of a reading material, you can use the learner's module. Open it in Unit 3, Module 1, pages 15 to 20. Okay, so for in this edition, we will be having the following parts: discussion, types of volcanic eruptions, and then another discussion on cones of volcanoes and types of materials ejected, and then a discussion on geothermal energy and geothermal power plants. And so first is for the type of volcanic eruptions. This is in figure number 72. You see Mount Kilauea. This is a famous volcano. If I'm not mistaken, it's in Hawaii. Yeah, Hawaii. And so this mountain, its eruption is called Hawaiian. Eruption is known to be Hawaiian kapag yung magma it flows out quietly due to low gas and silicon content. Yung eruption ni Mount Kilauea right here in this photo is known to be Hawaiian kasi yung magma nag-flow out siya quietly. Hindi siya yung ito yung uri ng eruption na ganyan lang talaga mangyayari. Mag-flow lang talaga yung lava palabas. Okay, so why does it do that? Because it has low gas and it has low silicon content. Kaya ganyan. Okay. And then this type of eruption is typical of volcanoes in Hawaii. That's the name. But it is associated with any volcano that has largely basaltic lava. So there are different kinds of magma. Remember, merong mga mafic, merong andesitic, merong felsic na lava. And if it's mafic, you can just expect that the lava will become basaltic. As you may see in figure number 72, lava from Mount Kilauea flows due to its thickness. Mababa lang yung kanyang gas content, yung kanyang silicon content, so you can expect na malapot yung magma. Kaya yan, mag-flow out lang siya. The second kind of volcano in this discussion is Mount Etna. So you may observe na meron siyang parang fireworks display dito, no? Ayan. So this is Mount Etna. Those are blasts, random blasts. Mount Etna, on the other hand, tends to shoot up some hot molten lava in the air in a dark night, as it is seen in this photo, as if it is a fiery fountain. Itong eruptive style ni Mount Etna is where viscous lava is thrown a few meters up in the air is called strombolian. Hawaiian, yung hot molten magma na masyadong thick is flowing. Whereas in Strombolian, may nag-shoot up na ng konti yung molten lava into the air, a few meters up in the air. So you can expect it na medyo mas malabnaw yung magma dito. It is quite related to the Hawaiian style of eruption since it also involves some thick and pasty lava, except that the hurling of lava into the air, it's instead of purely flowing out lava, typical of Hawaiian eruptions, meron siyang part na yung thick and pasty lava na hindi kasing thick naman ng Hawaiian eruptions, yung magma doon, is being shot up into the air. So again, for Hawaiian, nagfo-flow lang talaga yung hot molten magma, I mean yung lava. And then for Strombolian, may nagfo-flow, meron ding mga na-shoot up a few meters up in the air. Yan. For the next one, our example is Mount Krakatau. It's from Hawaii then. It's a third type. What you see here in the photo is a third type of volcanic eruption. And we call this Volcanian. Para siyang Strombolian eruption in a way that they both involve the blasting of volcanic material a few meters up the vent. Okay, they are similar in that. However, the blasts of volcanoes that are erupting through Volcanian eruptions are intermittent. Maya't maya, magbablast up magkakaroon na ganitong klaseng blasting. Okay, pero tas magiging quiet siya ulit. Okay, so again, mayroong blast, tas magiging quiet siya ulit. Why is that so? Because of the clogging of the vent with solidified volcanic material. Yung vent, kung saan dumadaan yung magma to become lava, is clogged with solidified volcanic material na soon is going to be broken by part as the volcano blasts. So, kapag nagba-blast siya ng ganyan, ibig sabihin nun, minimelt pa yung solidified volcanic material na sinasabi dito. Kumbaga, kiniklear pa niya yung throat niya. Okay. Tapos kapag naging clear na yung throat niya, quietly na lang siya magpapa-flow ng lava kasi wala nang obstruction. So, pwede na siyang malayang mag-flow, dumaloy. Okay. So, magiging quiet na lang siya nun. So, as soon as the volcano, as I've said kanina, clears all the clog in the vent, it undergoes quiet eruptions. Okay, so forming an eruption column in the process. Ito yung case ng Mount Krakatau. So, I hope that you can see the tall column of Mount Krakatau. Kasi nagba-blast siya intermittently. So, ma-form talaga itong column na to. This one right here is what we refer to as the column na napoproduce in the process of the intermittent blasting ng tulad ng mga volcanoes na nag-erupt through volcanic eruption. Okay, so for Hawaiian, quietly flowing. For Strombolian, merong flow, pero meron din siyang blasting few meters up in the air. For Volcanian naman, intermittent yung blasting, and then nako-form yung isang mataas na column. It's a really tall column. And remember, kapag natapos na yung blasting, wala na rin yung clog dun sa vent, and then magkakaroon na lang ng isang quiet na eruption. The fourth kind of volcanic eruption is one that happened in the Philippines. So ako, hindi pa naman ako alive nung year na yan. I mean, it's not actually funny. I am not alive yet nung time na yan, 1991 yan. And I was born in 1995. My mother just told me that it was a really dark era in their lives. Not just in their life as a family, pero it's life living near the volcanic eruption. There was ash, yung talagang ash na nagpo-fall from the sky. It is so difficult to breathe kasi like siguro apart from the pandemic, talagang kailangan ng mga tao dati talaga yan ng mga masks kasi if they're not going to use that, they will be suffering respiratory diseases. Apart from that, the change of weather, which led also to the lahar flow, it claimed so many people, and daming namatay because lahar. Basically, it was a really dark, really dark time in our history. Ayan, Mount Pinatubo, its photo here it was taken from Britannica. Its eruption noong 1991 is called Plinian. So if you compare the eruption column of Mount Krakatau in the previous Mount Krakatau, if you compare the eruption column of Mount Krakatau with the eruption column of Mount Pinatubo, you may agree that there's a huge difference. The eruption of Mount Pinatubo way back in 1991 is something you'll call a Plinian eruption. The eruption column niya is sustained in such a way that volcanic material such as ash is carried by the wind, and it is also spread in nearby areas. And since ash is so light, it really tends to just go upwards and upwards. And so this type of eruption is the most catastrophic of all the types of eruptions. Ngayon, meron tayong isang term pa to refer to really destructive Plinian eruptions. So if the Plinian eruption is so destructive, like it is more destructive than all the destructive Plinian eruptions ever in history, we can call it as ultra Plinian. So we can categorize that as as Plinian eruption, but if it is severe, then we can call it ultra Plinian. Those are the main types of eruptions. So we only have 4 talaga. Pero there's this one special type of eruption, which is called phreatomagmatic. So what is phreatomagmatic? Phreatomagmatic eruptions, I'm sorry, I pressed that. It involves the coming in contact of magma with a body of water, okay, or with ice, or with groundwater. So, kung walang visible na ice, walang visible na body of water sa surface na nag-come in contact with magma, pwedeng na-access yung water through groundwater. So, nasa ilalim siya. So, itong interaction ng magma with water, it results to a very, very hot, very hot steam that serves as an additional fragmenting agent. So, yung steam kasi, as we know it, it's charged with energy, right? It has the ability to cause motion. And since it is produced in the process of magma and water coming in contact, makakapag-produce ng makakapag-fragment pa siya. So, what do you mean about that is mas magkakaroon ng agent para mag-produce ng ash, para mag-breakdown ng mga geologic materials, say rocks. Okay, so since there is a steam, there is a greater possibility for the production of ash. Okay, so just to cut the long story short. Yeah. So observe that in this illustration of as a volcano in Japan, there is a gray ash around it because yung magma inside of it, it came in contact with groundwater. Yeah. And so those are the different types of volcanic eruptions. Ayan. So you remember these 5 types of volcanic eruptions because you will need to differentiate these in our assessments. Okay, I'm talking actually to my grade 9 students. That is a learning competency kasi you need to differentiate the active and inactive volcanoes, and so I'm adding to that is the different types of volcanic eruptions. You have to be able to differentiate them. Now we move to the next discussion, which is the cones of volcanoes and the types of materials they eject, or types of materials ejected. I have simplified this para hindi na rin gaanong maraming minimemorize sa mga estudyante ko. Pero I am sure that you will agree na aside from these, there are a lot of other different types of cones. Okay, meron pang iba't ibang uri ng cones aside from these presented here. Ito kasi mga pinaka-common talaga nilalagay sa learning competency ng mga grade 9 students in the Philippines, junior high school. So, this is where I'm sticking in so that they have an idea na kung ano pa yung mga iba. Okay, now we proceed with the cinder cone. For the cinder cone, ano kayang klaseng mga materials yung na-eject niya? We focus actually on the lighter materials here. I mean, cinder cones, yung na-eject niya usually are lighter pyroclastic materials such as ash, projected upwards. So, since upwards yan, they just tend to go back down. And that kind of mechanism causes the vertical increase in size of the volcano. So, mas nagiging matangkad siya. And so yung sides niya mas nagiging steeper. Ayan. And then for the second one, when it comes to shield cones, ganito yung tsura niya. Para talagang shield siya na nakatumba. Okay, so mas malapad siya, di siya gaanong katangkaran. Mas malapad siya kumpara sa mga cinder cones. It's because they have more viscous lava. The lava is thick, so it is only flowing sideways. It makes the volcano appear wider than it is steep. Yeah. And then the next one is a composite cone. For composite cones, it's a combination actually of the characteristics of both cinder and shield. Meron siyang fair amounts of light and silicon-rich pyroclastic materials, and then it also has viscous lava, making it grow steeper and wider at the same time. And so matangkad siya, and then malapad din siya. Okay, so that's it for the types of cones of volcanoes and the kinds of materials that they eject. Yeah, this is this is a very easy and very fast part of the discussion, pero I hope that you understand. We simplified all of this for grade 9 students. Okay. Yeah. So now we proceed with the last part of this session, which is geothermal energy. So I believe that you're watching this video now through a laptop or perhaps through a phone or any other device like a tablet, which is electronic, or also it also requires the input of electricity or electrical energy. It actually came as a surprise for me to learn that geothermal energy plays a very important role in energy production, electrical energy production in the Philippines. You're familiar perhaps with geothermal energy? Okay, if not, let's formally talk about it. Geothermal energy is a form of thermal energy, that is stored deep in the surface of the earth. Okay, so this thermal energy comes from a variety of sources. It comes from different types of sources. It can come from the decay of radioactive substances, or may mga elements kasi na super radioactive. So when they do decay, every now and then, nagre-release din sila ng energy. And that energy is deposited in the solid layers of rocks. So what we're saying here is ganito. Kung merong init na nagagaling mula sa surface, beneath the surface of the earth, saan naman naggaling init na yun? Since, di ba, energy is neither created nor destroyed. So, saan nagagaling yung init na yun? So, the first source is that thermal energy comes from the decay of radioactive materials. And then the next possible source of that thermal energy can come from melted magma, as in the case of volcanoes. So volcanoes are areas of high geothermal energy systems for this reason. Now, it was not mentioned in this, in the text, pero one other source of geothermal energy is, kung saan nagagaling yung init, yung thermal energy. Aside from decaying radioactive materials, it can also come from the remnant heat of the Earth from its formation. So the planet formed billions of years ago, and so nag-differentiate din siya. So yung mga layers natin ng geosphere, they were formed because of differentiation. Okay, so that process actually still continues in some ways, okay, up until today. And so because of differentiation, continuing minor types of differentiation, yung init is nagagamit. Okay, although it is being transformed into many different ways. Halimbawa yan, yung geothermal energy, we can transform it into electrical energy, and then in turn transform it into other forms of energy. Okay, so, but it will never be destroyed. Okay, again, energy is neither created nor destroyed. Also, may mga thermal energy rin na nakukuha talaga tayo na nade-deposit surface ng planet from the sun. Okay, so that's the third source of energy, of geothermal energy, the sun. And so, for a power plant, I mean, for the concept of geothermal energy, we need to analyze muna figure number 79. And so figure number 79, it shows you what we do on the surface, what is happening beneath. So the magma beneath a layer of intermediate bedrock serves as the heat sources of an entire geothermal system. Kapag merong deposit ng magma, tapos meron siyang way out, say for instance, ayan, nagkakaroon ng geothermal system din doon. Adding up to this is groundwater. So colored light blue right here. Okay, groundwater is heated by the layer of magma beneath the intermediate bedrock layer. It causes it to move in a particular current. And it causes it to move in a particular current. This movement allows the seeping of some heated water through cracks, in the rocks above it to escape it in the surface as steam. So, yung groundwater right here is being heated by the hot intermediate impermeable bedrock, and then itong flow ng current is being formed because of that. Again, merong init dito. Since meron tubig dito, magpo-form siya ng current. Init, tubig, magkakaroon ng current. And then that movement of that current of water, of groundwater, will energize it enough to move it through crevices, yung mga cracks dito sa cap rock, dito sa permeable cap rock. So may mga parts yan na na pwedeng labasan ng steam pag-releasean ng highly pressurized steam. And at yun yung ginagamit natin for geothermal power plants. So yung steam na nakita niyo sa figure number 78, ito, as well as yung steam na nakikita niyo dito sa taas dito, they both mean the same steam that comes from the seeping of heated water through cracks in the layer of rocks above the groundwater. Okay, so ayan. A geothermal power plant has the following, it has a very simple setup. So groundwater is heated by the hot layer of magma. I found at the bottom of figure number 77 right here. So yung very thin na red line right there is it is representing the high temperature ng magma na hinheat up yung blue layer. Ito naman blue layer na to, ito naman si water. Tapos ito yung permeable na cap rock na sinasabi kanina. So dyan pwede mag-seep yung hot water. Yung hot water niyan, pwede siyang ma-pump through pipes towards a chamber right here to produce steam. Tapos yung steam na yon, since it is highly energized, it can cause motion. So pwede siyang mag-cause ng motion. And by saying cause ng motion in the turbine. So yung turbine, pwede siyang umikot because of steam that is passing by. Remember, steam is energized, it can cause motion, and in this case, it will cause the motion, it will cause the turbine to move. Ayan. So when it moves, the turbine will be activating the power generator, and the power generator is where the electrical energy is going to be produced. Ayan. So first is iinitin ni magma layer si water, and then si hot water is going to be pumped right here into this chamber, and then the steam will be deposited here in this tube. To cause motion in the turbine, and then the turbine is going to receive that motion, making it move, and then ma-activate niya yung si power generator. Ayan. Tapos, anong mangyayari? Since nag-generate na ng power si power generator, it can now bring that voltage of electricity to transformers para mas mapaliit yung voltage, hindi masira mga appliance natin sa bahay, and then matatransmit na siya through transmission lines. And tapos ano mangyayari naman sa steam? We'll be discussing that later. Pero I hope you see these familiar energy electrical energy towers. Ayan. Okay. So, yan, through those distribution lines, ma-reach ng electrical energy yung mga bahay natin. And specifically, yung mga devices na ginagamitan natin ng electricity. Now, pagka tapos na mag-pass through sa turbine yung steam, it will lose a very significant amount of energy. Okay, so it will lose a very significant amount of energy kasi meron na siyang na-transform na yung energy, di ba? From thermal energy, naging mechanical energy. The mechanical energy that was caused to the turbine. And then the mechanical energy was turned into electrical energy. So since ganun yung nangyari, nag-transfer na ng energy sa steam, mawawalan siya niyan ng energy. And then magpo-proceed siya sa cooling tower. Dito sa cooling tower naman, yung steam, makikita mo talagang, ayun, nag-escape pa siya. So while some parts of that liquid, yung vapor part niya is being released into the atmosphere, some of it becomes liquid, okay, and then it goes back through the injection well into the aquifer or the storage of water right beneath the permeable cap rock. Ayan. So, ayan, that's the entire process of geothermal energy. That's the entire process, simple process of that are observable in a geothermal power plant. In the Philippines, we have the following geothermal power plants. This one is in Kidapawan, or in Cotabato, if I'm not mistaken, nasa may Mindanao area. So, geothermal energy is known to be a renewable energy resource. Because the water, yung water na ginamit, that was used, again, turning the turbine, gets replaced by rainfall and other forms of precipitation if kulang yung na-condense na water na binabalik through the injection well. Yung thermal energy naman na ginamit naman para ma-produce yung steam, it is continuously generated by the thermal energy of the magma beneath the surface of the earth. Ngayon, itong steam na nakikita nyo dito sa Kidapawan Geothermal Power Plant, yan na yung nanggagaling dun sa cooling tower nila. Okay. Ayan. So, this is the discussion. This ends the discussion for geothermal energy and geothermal power plants. And so for this video lesson, we were able to finish the following discussions. The first one is a discussion on the types of volcanic eruptions. The second part is a discussion on the cones of volcanoes and types of materials ejected. And then the last part is a discussion on geothermal energy and geothermal power plants. This is Sir CJ. Okay, this is Sir CJ, and I hope that I will be seeing you in the next video. I would like to thank you for the support that you are giving this channel. And I hope that you will, if you're new, you choose to subscribe and like this video if you learned something. And I hope that you will be sharing this to teachers and students who are just like you, learning and teaching grade 9 science. I'm very much willing to share my resources with you. So if you want to contact me, you know how to find me through my Facebook account. This is the Knowledge Catalog. I hope to see you in the next video. Have a good day.